All right, so welcome to Lecture 5. This is iOS. So we started talking last week about Objective-C and really just the syntax, and we used it only in the context of macOS-based applications, command line applications. So today we actually introduce stuff that's germane to iPhones and iPads and the like. And the nice thing is that a lot of the topics that we're going to start playing with, we really did play with already in the context of PHP, because the iOS SDK, Software Development Kit, is all about MVC, Model View Controller. And so you're going to see the same paradigm, but realize you're going to see some different jargon. You're going to see lots of different features of the GUI. And for the most part, what we'll try to do this week and after spring break is guide you through what might otherwise be a little overwhelming or complex so that you're empowered both for Project 2 and 3 to dive in and make something of your own. So recall that we changed labs a while back, and just so that folks are taking advantage of these things, we do have this cycle whereby the first week after a project's out and you've submitted your design docs and style guides, that Tuesday, Wednesday, Thursday are meant to be design reviews. So rather than have to wait several days to get feedback via email as we tried for Project 0, the idea here is that you and or your partner can drop by, consult with one or more of the TFs who are there, and get immediate feedback so that you don't have to have some artificial delay before you can really dive back in. So don't wait on us. In fact, if you want feedback via email in addition to these design reviews, per my email a couple weeks back, it's expected that you email your TF with any and all questions that you have. Otherwise, we're there as this resource 3 times a week. Code reviews are the same idea once you've submitted your alpha, so that's what we'll do this coming week. And then the week before releases are due will be just general open office hours. So with the first 2 of these, expect the TFs to proactively come up to you and say, hey, you want to give me a quick tour of your design and or code? Office hours, you are meant to raise your hand or draw us over to you. All right, so here was the simplest of Objective-C applications. The difference, even though we spoke only briefly about it, between import and include, as we see in C, is what? Yeah.
Import only includes it once.
Perfect. Import only includes it once, so like PHP's require once, you get that same functionality. You don't have to worry about doubly including it. And because if you did have to worry about that and you had some class definition or some global variable, you might accidentally doubly define it, and the compiler would not like that. Foundation.h just refers to Apple's foundation classes. These are a lot of the things that start with NS, next step something, and these are either primitives that are typedefs for things like ints and chars, or they are more interesting things like NSString and actual classes that we started playing with. We'll see some more today. Int, main, argc, and whatnot, that's pretty much the same as you might see in C. We're not really going to use that henceforth in iOS because there is no command line per se in these applications. They're GUIs, but we'll still see a main function. It's just you won't need to write it anymore. At auto release pool. We'll talk more about this after break in the context of memory management, but for now, just assume that this is the magic that handles memory management for you. You don't need to worry about calling free. You do need to worry about calling alloc once in a while, but you don't have to worry about, again, the converse. And we'll talk about why before long. This is a relatively new feature. So again, if you're using older books or online resources, it didn't exist before June, give or take. So just realize this is a new feature of iOS 5. NSLog is a proper logging function, but for our purposes, it's pretty much like printf. It lets us see things on the console. You wouldn't typically use it in your production code, and return 0 is just as we've seen in C. So that was a quick rapid tour of where we left off last week. Any questions about the general framework here? Yeah?
If you do log something on like production code, what does that do on the actual iOS device?
Good question. If you recall NSLog in production code on a program you've burned into your phone or iPad, it will actually get logged to the device's memory. And if you connect it via iTunes or rather with Xcode, you can actually see those logs. Not all that helpful if you have thousands of users elsewhere, but for debugging purposes, you can use it that way. But generally, they should be turned off because it's just going to clutter disk space unnecessarily. Good question. All right. So this was now object-oriented programming. So we had some abilities to define what we call classes, which are like templates or molds out of which we can instantiate objects, specific incarnations thereof. Just recall that the jargon in Objective-C is to say at interface. So those of you who knew Java, this is like the keyword class. PHP, it's like the keyword class, but they call it interface. The colon here denotes what? Colon after the class name. Yeah, inheritance. So this just means that foo descends from the NS object class. And what descends means in object-oriented programming is you inherit everything that NS object has. So if it's got methods, if it's got data inside of it, the foo class gets all of that stuff plus it can now add its own thing. So this is a useful thing when trying to create some kinds of hierarchies or to avoid having to reinvent the wheel. Recall that we had the alloc method and even the init method, and even if we didn't implement those ourselves, we did have them, and that's because we stole them really from our parent class NSObject. So typically, you'll descend from this if you want that functionality, but it's not strictly required. Inside of the curly braces, you can put instance variables. What's the difference between an instance and a class variable? I know, yeah.
Unless you instantiate the object, you can't use the methods.
Perfect. So unless you instantiate an object of the class, you don't have instance variables accessible to you. By contrast, class methods or class variables, or static variables as they're sometimes called, exist inside the class itself, inside the mold, and are shared then across all instantiations of the object. So for the most part in Objective-C, to be honest, we'll almost always use instance variables, but we'll point them out if we ever need to do something a little different than this model. And then lastly, and don't forget the syntactic confusion, the declarations of methods with minus signs or plus signs go outside the curly braces, but before at end. And it's not strictly necessary to even have these curly braces if you have no instance variables. So you'll see in Apple's templates for iOS 5 that sometimes that's not even there. But don't worry, it could be there if you had instance variables. So another thing we're about to start seeing today and onward is this use of something called categories. In Objective-C, you can augment the functionality of a class by defining a category. If you know JavaScript well, you can think of this as extending the prototype of an object and adding functionality to an existing object or class, so to speak. And you can also think of this kind of like inheritance in that you can add functionality to an object, but without having to extend it and without having to create some hierarchy. So what I mean by this is this. If we have on the previous slide a class called foo, and it's got some methods, and we decide, you know what, we want to add some more methods to this, even if it's an existing class that we ourselves didn't write, like NSString, you can add methods to it by saying, again, at interface foo, and then in parentheses, an arbitrary name for the category. So I chose bar arbitrarily. A common convention is to put no name whatsoever, open paren, close paren, that says here's a category, or really the jargon here is here's a class extension, which is maybe more clear than calling it a category. And then when I say dash void baz, that's defining a new instance method called baz, returns void, takes no arguments, but that's now part of the foo class. It's just in a category unto itself. So this can be used for a couple of reasons. One, it allows you to add functionality to classes other people wrote without having to extend them. And this is useful for now, just assume, because it allows us to add some functionality over here, over here, over here, without having to come up with this rigid vertical conceptually hierarchy, and that'll make more sense in the future. And it also allows us to impose some kind of visibility constraints. It's going to allow us to add secret methods, if you will, or secret properties to objects without having to declare them in our .h file. But we'll see that. Yeah?
Can you use it like a mixin, or is it?
Yeah, that's exactly the idea here. Yeah?
If you wanted,
Oh, you first, Charles.
if you wanted to call that baz method, would you need to create an object of type bar? Or would it still be an object?
No, so bar is not a class. Bar is the category name, and for the most part, it's arbitrary. It just needs to be unique. Foo is still the class name. So you would need to create an object of type foo in order to pass it the baz message, aka call the bar method. Baz method. Yeah. Same question. OK. All right, so a little, oh, yep, Kevin?
If you had say a method called baz in the original class, would it overwrite it, or does it raise an error, or how does that work?
Oh, that's a good question. Tommy, do you know the answer to that? OK, neither of us know. We'll try to figure I don't know. If you actually try to override the method name but in a category, I'm not sure, but let me check. If you do inheritance, it overrides it. I'm not sure of the behavior in a category, but easy enough to test. All right, so a couple other building blocks of Objective-C, and then we'll transition to Xcode and iOS GUI stuff. So a protocol is one other thing that I think I mentioned in passing last week, which is similar in spirit to PHP's and to Java's interface. Again, not to be confused with Objective-C's interface, which means class. In this case, a protocol, as specified in angled brackets there, means that this class implements a whole bunch of methods that are declared in a protocol called nscopying. So in other words, there's some file, probably nscopying.h on the system somewhere, and it lists, top to bottom, a whole bunch of instance methods and or class methods with minuses and pluses. That's all it does. Arguments, return types, all of that. When I now declare a student class as implementing, in angled brackets, the nscopying protocol, that just means that I am promising to implement all the methods that are listed in that .h file. That's it. So it's a way of standardizing functionality that different objects implement so that you can be guaranteed that they'll respond to certain method calls. And in this case, nscopying, what does this mean? This actually refers to, it's an Apple Foundation class thing. This just means that the student object can be copied now in a standard way. Because what does it mean to copy a student? Well, we talked about these issues in CS50, for instance. Do you copy just the data members inside the structure? Or do you recursively copy the actual strings, allocate new space for the strings when copying a student so that you're not sharing names across students and the like? So those kinds of issues. How do you truly make a copy of a student object intelligently, not just copying all of the individual bits, which might include pointers? Nscopying essentially standardizes how you do that by way of implementing a copy method. So we'll see eventually some uses of this, but for now, this just means interface in PHP or Java if you come from that world. But for now, know that it just means you're implementing a certain bunch of methods. And this will make a lot more sense as we start poking around documentation, and you'll realize, oh, it just means that this class implements X, Y, and Z. So again, just a piece of jargon for now. Now for error handling. How does Objective-C and iOS handle errors in general? So on the one hand, you can certainly return sentinel values from functions. You can return no, the synonym for false. You can return -1 or 0, whatever the convention might be. But you can also have some back-channel ways of signifying that an error has happened. In C, we didn't really have this capability. In C, the best you could do is either return some special value, or you could accept an argument via pointer and then store at that address whatever error code or error message you have. And we didn't see this much in 50, but in C, this is actually quite common. You can effectively return multiple values in C by passing in multiple arguments by way of reference, not value. Because if you have references, you can put as much stuff in them as you want, which is functionally equivalent to returning multiple values. It's just a little messy. It's not very clean. So in Objective-C, you have a couple of mechanisms. You have exceptions, and we have these in Java and PHP and in other languages. And an exception looks a little something like this, whereby if you know that some method might throw, quote unquote, an exception, trigger an error, you can try to execute that code. So @try, curly braces, and then the code that you think might throw an exception. Why might a function throw an exception? If you try to open a file that doesn't exist, if you don't have read or write permissions, or something like that, that you would hope is not going to be the case, but it might 1% of the time, and you want to handle that scenario somehow. So if, though, there is an exception, and you try and fail to execute that line of code, the way exceptions work is that you immediately jump into the block of code in the catch statement. You are passed by pointer an object that contains juicy information like what line number did this error happen in, what function did it happen in, what was the error code, what was the human-friendly error message. Depends on the language. In this case, NSException is one standardization of this idea. And then however you want to handle this exception now is up to you. You can you can quit entirely, say sorry, something went wrong, play again, or you can try to recover somehow. And finally, anyone know what this does? Other languages have this as well. Yeah?
It's guaranteed to be executed after the try and or catch.
Exactly. It's guaranteed to be executed after the try or after the catch so that it always happens. So finally is useful for stuff like closing a database connection, closing a file, something that you really want to be sure happens, and you want to make sure it happens even if there was an error. So it avoids a little copying and pasting of code in both of those blocks. OK, so that's one mechanism we will see. And another one is sort of the older school approach that I alluded to as a solution in C, whereby there's also a class called NSError. And an NSError object then can contain things like an error code, a number, and a human-friendly error message. And the convention with some iOS code is that if the bar method, or rather if, let's say, so if rather the foo object might actually trigger an error, you can pass in a pointer to one of these NSError objects so that its contents can be filled with that error code, with that error message, by the message that you're passing. So in this case, the message is called bar error. Recall that we have these sort of weirdly named parameters where they're broken up by spaces and or colons. So in this case, if this method call, we'll call it, returns an error, it's going to do that by essentially inside itself doing *e, go to that structure, filling it with an error code, filling it with an error message, so that effectively this is passing back more than just nil in the case of an error. Okay, so in short, this is the second way we can pass errors back and forth. Yeah?
Where does the allocation take place?
Where does the what take place?
The allocation of the NS error?
So in this case, it would, actually, that's a good question here. Does it handle it itself? I believe, let me double check. I think the convention with some functions is actually to allocate it for you, but because this was deliberate that I initialized this to nil, but let me double check on that, just to be safe. Yeah. Other questions? OK. All right. And that's it for Objective-C. All right, so hopefully we have a lot of the building blocks. The syntax you'll get more comfortable with, and we'll start seeing it quite a bit. But now we can move on to iOS itself, iPhone programming. But any questions? All right, so thankfully, the stuff we're about to start talking about is actually quite familiar. At least it's familiar if you wrapped your mind around it the first time around, in the context of CodeIgniter and PHP. So in MVC, you again have models, views, and controllers. And in an English sentence, what's a controller? What does it do? Yeah.
Allows the model to communicate with the views.
OK, so it allows the models to communicate with the views. I would tweak that a little bit in that it allows you to take data from the model and pass it to the views. It should really remain the middleman. But sure, and more generally, it controls really the whole logic of your program. What is a model meant to do? To find data. So the model talks to your database, or it represents some real-world entity, like a student model could represent a student, or a student's model could represent a whole collection of students in a database. And how about the view? Yeah.
Just presents all the data to the user.
Yeah, it has to do with presentation. And so what's nice actually in the world of iOS is that once Apple released the iPad, people didn't have to go out and rewrite the entirety of their applications if they wanted to then port the same code base to the iPad, whose screen resolution was bigger, the screen itself is physically bigger. You can simply implement some additional views that maybe have more on the screen or at least blow it up. But it was relatively easy to make that kind of transition and will continue to be so, especially if the iPad 3 or whatnot has even higher resolution and the like. You can simply have different views for different hardware. Same thing can be possible with Java in the Android world. So we're about to start making heavy use of UIKit. So this is just another library from Apple, similar in spirit to the foundation classes. UIKit refers to user interface mechanisms. And the buzzwords, or the classes we're about to get quite familiar with, are UI application, which is a class that represents an iOS application. UI application delegate, which really represents the brains behind a iOS application. It's to whom you delegate control of the application, as we shall see. A UI view is just a view. It is a very generic class that represents the notion of a presentation layer. And so when we see things like buttons and text fields and the like, turns out those are going to be descendants of a more generic class called UI view. So a UI view has something to do with aesthetics and presentation. So all the little user interface widgets with which you're familiar on your smartphone are going to descend typically from that class. UI view controller. Now this is where Apple jargon gets a little confusing. A UI view controller is a controller. What it's controlling is views, which is not all that different from the conversations we've had thus far, but it's not a view. They just call it view controller, and it would be nice, frankly, if they just called it UI controller. But it's UI view controller. But it's just a controller. OK. And a UI window is actually itself a special case, as we'll see, of a UI view. So the UI window essentially refers to a class that represents the rectangle that is the screen on an iPhone or an iPad. Inside of the UI window, you can have multiple UI views, little rectangular areas like divs in HTML, or UI buttons or text fields. So there's going to be this whole hierarchy also. And this is where object-oriented programming is, again, useful. We can have these hierarchies of inheritance so that you can divide this rectangle into little parts, each of which itself is some kind of view, a specific type of view. All right. And templates. So as we saw terribly briefly in the past when I made the stupidest of iOS applications and called it an app by just writing hello world or the like, that was expedited because the Xcode comes with these templates. We could start with a completely blank .m file, completely blank .h file, but frankly it would take like 20, 30 minutes to actually configure all of the various settings in the IDE, to talk to the compiler, to talk to the simulator, and actually get the beginnings of a hello world application going. So you almost always in iOS just start with one of the templates. Maybe the minimalist template, maybe the maximal template, and then you start ripping things out and adding to it. So just realize that these templates are not themselves doing anything magical. It's just someone at Apple spent the time wiring things up, writing some often poorly commented sample code that they then called a template just to make some things easier. But realize that, again, stylistically, they're frankly a little bit of a mess. White space, indentation's not always correct or not always consistent. But realize you can do anything in iOS from the bare bones template. It just might take you more work. So just realize those exist. And then lastly this summer, in addition to automatic memory management, automatic reference counting coming around, which again we'll talk about in a couple weeks, Apple introduced the notion of storyboards. This is meant to make easier the process of putting together an app, because many, not all, iOS apps have like screens where you touch a button and the thing scrolls to the right. Touch another button, it scrolls to the right, or something like that. So not Angry Birds, but more of a data-driven application. And so storyboards are meant to facilitate that type of application where you touch something, you see new content. Touch something, you see new content. Not so much graphical, but a standard UI mechanism with like a little scrolling view or buttons or scroll bars or the like. So storyboards allow you to really paint a picture like this on what looks like graph paper in the user interface, where you can drag and drop these things, and then these arrows that are a little faint on the overhead in gray represent segues or transitions, whereby you define what should happen when the user transitions from left to right, and then further to the right, and so forth. Storyboards do not enable any fundamentally new functionality. They're just meant to make things easier. They're a little complex. In fact, the template that Apple ships that includes storyboards, the templates, are frankly a little complex. So we'll start today with nib files, simpler user UI mechanisms, but this is just a layer on top of what we're going to keep calling nibs, little user interface widgets that make it easier to program things. All right, so that's it for jargon and sort of exposure to broad concepts. We can now dive into some code if you'd like. All right, and so this is a bit of an anomaly. This week, I actually printed out handouts simply because there's a lot of code and a lot of new syntax. So do feel free to either follow along on your laptop, the code's online, or to actually follow along here. And this is definitely the sort of thing whereby if you get lost, you kind of then lose track of the rest of the conversation for a while. So please interject at any point with questions, confusion, and the like, and feel free to grab some handouts if you didn't yet grab them. All right, so the first file I'd like to turn our attention to is called student7. So there were a couple of, remember we had this series of student-related files, and let's just round out that conversation by adding a couple of new functionality, a little bit more functionality that lets us solve problems, as we'll see, in different ways. So let's look first here at student.h. So this is student7, student.h. And this file simply looks like this. So recall that a student last week descends from NSObject, for the moment has no instance variables, apparently, and there's nothing in the curly braces, but it does have two properties, a property called age and a property called name. So just as a refresher, since we have to start taking this jargon for granted soon, what is a property in Objective-C? What's a property? Give me any recollection you have of this word at all.
Variable belongs to the class.
OK, a variable that what?
Variable that's part of the class.
OK, it's a variable that's part of a class, but it's not quite an instance variable per se, but there is often this one-to-one mapping. So a property, yep, Charles.
Well, it'll create the getters and setters for it.
OK, good. So if you declare a property for a class, as I did for age and name, this enables you subsequently to use the special keyword at synthesize, which recall just saves us, frankly, a lot of work. It synthesizes. It automatically creates for you, thanks to the compiler's cooperation, what types of methods? Getters and setters, right? Unlike the world of Java where you copy-paste ad nauseum to create getters and setters, Objective-C can do this for you automatically. It also, a property, gives you some syntactic sugar. What does declaring a property also let you do? It lets you use, dot notation. So instead of having to write something like if S is a student object and I want to get S's age, typically I would do this. And this would return to me the value of the age method. Well, or if it's actually an instance variable, I could do this, which we've done in C, which we did at the beginning of last week's lecture. Both of these are fine. This is direct access. This is a message access. But this, frankly, is just a little ugly, especially if you start nesting things. So this can be simplified to just s.age, where the only difference now between s.age and s_age is that, again, this is direct access, but this is actually invoking what? The getter. And that's useful because the getter might do a little more than just return the raw value. It might return 0 if it's just undefined. It might just behave a little bit differently. So that's useful. But more useful, too, is that if you also say something like the other syntax we saw a bit was s and then set age. Recall that the convention for setters, by human convention, is the word set in lowercase, followed by the variable name in uppercase. And so the convention here was to say set age, let's say 21. This now gets simplified to what syntax? Thanks to properties. This is not, now we're blocking you people. What does this get simplified now to? Exactly. S.age gets 21. And now properties are getting more compelling, frankly. Syntactically, now this is actually useful. So properties are used throughout the iOS framework. It's a good habit to get into. You still need instance variables to store the data, but you don't need to declare it explicitly because when you call synthesize, what can you do? You can do this little trick. You tell the compiler, synthesize this property. In other words, generate for me, getter and setter, but back that property with this named instance variable, _age and _name. Now this too is a convention. It is perfectly legitimate to just do this. Synthesize age, synthesize name without the equal sign. And take a guess. What do you think the instance variable will be for each of those that's automatically generated by synthesize? It's just age and name. So that's pretty good. But the difference here is just, again, a human convention. Often, if you want something to effectively be private, there's this convention of using the underscore so that it's not conflated with methods, which are typically named without such underscores, at least in iOS. All right, so this is Apple convention. So for the most part, if you look through Apple's templates, you can pretty much infer what conventions they want the world to adhere to. And frankly, it's a moving target. The templates themselves have changed over time, and Apple's own style has been evolving. So it's fine to pick your own, but probably best as a starting point, just go with what Apple recommends. So your code will look like the rest of the world's. All right, so now in the .h file, we had just one other thing besides properties. We had a declaration of an initialization method. This too is a common paradigm in iOS. You typically get an init method, even if you don't define it. Where is the init method actually defined? In the NSObject class. But it's convention also to have init with foo, init with bar, if upon initializing the object, you want to pass in some value or even some values. So in this case, I decided, you know what, for a student, rather than have to instantiate the object with alloc, then call the generic init, then call two setters to set name and age, let me do this all at once. Let me have an init with name, and that takes a name variable, and age, and an age variable. And now I can set both of those things at the object's initialization. I have to implement that thing myself. So in the .m file, recall that we did this. Below the synthesis of those properties, we had a declaration of init. Now I'm overriding the NSObject class's initialization, just because I decided that I want John Harvard and his age to be the default for any student object. Just because. I didn't need the init declaration in my .h file, though. Why? Why did I not need to declare this init method that I'm implementing in the .m in my .h, even though I could have? What's that? Inherited. Same answer as before. It's because NSObject.h already did that for me. So you can do it, but it's not necessary. So in this case here, notice the convention. Self is like this in PHP and Java and some other languages. And notice the convention in iOS 5, older textbooks and older templates don't do this, is to make sure that when you call your initialization method, you reassign it to self. So update myself to be the result of calling init with a name and age, and then return self. And this is, again, an initialization method. Ultimately, it's got to return itself, but it can do some preliminary changes to it like this. Now, init with name, same idea, but it's a little more explicit. So here, the convention in any init method that descends from the NSObject class is to call super init. And for those familiar or just a guess, who does super refer to? The parent class. So in this case, call the NSObject class's init method. I don't know what it does, and secretly it doesn't do anything, but Apple makes no promises that it's not always going to do nothing. So you better call it as a matter of best practice. So call super init. Odds are nothing's going to go wrong. Maybe something will go wrong, but odds are nothing will go wrong. But again, to be extra rigorous, make sure that it returns non-nil value. And so assuming it's OK, go ahead and set self.age equals age, self.name equals name, and then return self. Now, I could have copied and pasted this code up here, but this is probably better design in that I'm reusing my own code by calling one init method, the more explicit one, from the more generic of the two. But this is not even strictly necessary. If I'm OK with having nameless, ageless students, then I just don't implement that default init method at all. And so this init method is similar to what feature of PHP, what feature of Java? It's the constructor. So new is like alloc, and these init methods are like the actual constructor functions, or methods rather. All right, so here's the new feature where we left off last time. So this is a main.m in version 7 of the student class. And notice that I again have the prototype for this greet method up top. And I again have my main method here. I again use auto release pool. For now, let's just assume that that makes some magical memory management happen for me. But we'll come back and peel that layer away before long. But here's the new thing that we only touched on briefly last time. If you want an array in Objective-C, you can use NS mutable array or NS array. And the difference is as their name suggests. NS mutable array means it's changeable. You can add to it, subtract from it, and the like. NS array is immutable. Popular CS word for just means unchanging. Once you create it, that's it. So what was our answer last time to the question of why would you want a mutable versus immutable? In C, we always had mutable arrays. Yeah? Performance. There's just some optimizations you can do. If you know the array is never going to change, you don't need extra code, you don't need boundary checks or anything because it's not going to change. And so a NS array is good when it's static data or data whose length is known in advance. A mutable array, though, is necessary if you just don't know or if you want to demonstrate mutable arrays. So in this case, common paradigm. And just to be sure, you guys in back, you can read this font size OK? OK. So NS mutable array star students, this is CS50 stuff, like declare a pointer called students of type NS mutable array. The right-hand side is the new stuff, but we've seen it a couple times now. NS mutable array is the name of a class. Alloc is a class method, which means we can get away with calling it without instantiating an object yet. And that's good, because otherwise we'd have a little catch-22 here if the goal is to allocate an object. And then init, which is very commonly just put in this nested form so that you're calling alloc, then init immediately. Much like in other languages, you would call new and then the constructor. And what do I get back? I get back, hopefully, the address of an actual NS mutable array object. Now, if I were being really rigorous, I would check return values here and the like. But for now, it's actually OK, especially since nil, as we'll see. You can still call methods on nil without things crashing. But more on that when we talk more about memory. So now, just some methods. Students is now a mutable array. I'm going to call an add object method and pass it what? Well, I'm going to dynamically allocate a student object, immediately initialize it to Alice, whose age is 20. And that's what I'm going to put first into the array. Add object, if we read the documentation, appends it to the end of the array. So Alice just went at location 0. And the method called add object handled that for me. Now, just to be anal about jargon, I keep saying method because it's the more familiar terminology. But technically, what we're doing here is we are passing an add object message to the object called students. But functionally, these are the same ideas. But you'll see both types of jargon. Yeah, Zach? OK.
I can imagine that eventually you'd have an init method that had a lot of things that you'd be passing in. Does that just get really long?
Good question. When you start having many, many, many parameters, what happens? Yes, it does get very long. What you'll see is Xcode will actually start automatically indenting your code so that all of the parameters line up key value, by centering them on the colon. So if you're familiar with LaTeX, it's like lining things up with the equal sign. So it's actually nice in that sense. Order still matters, but at least formatting is not such a big deal. All right, so next, Bob, uninteresting. We do the same thing, give him a different name and a different age. And this is just what we call fast enumeration. PHP has this, Java has this now. For each, this is like the for each construct. On each element in students, temporarily assign it the pointer s, and then do something with s. In this case, I'm calling greet, whose sole purpose in life is just to print Bob or Alice's name. So the only takeaways here, again, are the introduction of this collection class, NSMutableArray, the syntax for calling this, but it's not really new syntax. It's just getting a little more complex aesthetically because we're nesting and using assignments and the like. Any questions on any of this thus far? And again, honestly, please speak up now so that you don't feel lost. OK, not lost. Excellent. So let me go ahead and pull up version 8 of this here. So version 8, I think I have to stop numbering these and come up with more exciting names because it just feels like a huge long list otherwise. But this one's easy. So this is just an example of demonstrating immutable arrays in the scenario where you know what the list is already. For marginal performance benefits, you just want to hard code that list. And so in this case, I didn't even bother creating a student class because I just wanted to store strings in this case. So now notice here, I create an NSArray pointer called names. Then I call NSArray array with objects. And apparently, and this is funky syntax now, if you want to pass in multiple values for a single parameter, can't usually do this, you simply separate them via commas. So this is going to create an immutable array whose objects are Alice, quote unquote, at location 0, Bob, quote unquote, at location 1, and essentially the null terminator, really the nil terminator at location 2. And so now we have an array of fixed size 2. So what am I not calling in this line of code that I have been calling up until now on every class? Alloc. So there's no mention of alloc, and yet this has got to be somehow dynamically allocated, right? So it turns out that a very common paradigm in Objective-C also is what are called convenience methods. A convenience method is one that is named pretty much consistently with what it does. In this case, array with objects. Give me an array with objects. Now to do that service for you, it has to call alloc for you. So these convenience methods are plus methods. They're class methods. They call alloc for you. So why is this useful? Why this sudden new feature here? Go with the obvious. What does your gut tell you? What's that?
We don't need to call alloc.
That's it. You don't have to call alloc yourself. It's a convenient method in that it's convenient. It really is as simple as that. It just avoids this increasingly annoying paradigm of calling alloc init. Alloc init, you just say array with objects, and then you can tell it what you want to allocate and initialize simultaneously. So someone had to write array with objects, but it is another example of a class method that's a little more interesting than just alloc itself. Yeah?
So the array with objects, it doesn't have to have like the same type of objects?
No, it does not need to have the same types. So this is unlike a lot of languages, and in this case we can put whatever we want in this case. Now, it's often bad design to put strings and strings and other objects, student objects, all commingled, unless they all descend from some parent class, which then conceptually makes sense. But yes, you could do that. Yeah?
Before reference counting, we have to create ourselves.
Before reference counting, you would not have to free this because this would be added to what's called the auto release pool by having passed an auto release message. So that detail, though, is now swept under the rug. But we'll come back to that and lift the rug in a couple weeks. Yeah, Zach?
And the array with objects is reserved for immutable arrays.
In this case, so this is one of these RTFM things. Like if the documentation says that there is this convenience method for the NSArray, it exists. And I believe it does also exist for NSMutableArray.
So we could have done that in the last.
Could have, yes, exactly. Only because someone wrote it that way and we confirmed as much in the documentation. Doesn't necessarily have anything to do with mutability. Yeah?
We need to give it nil to tell it how many objects are in it.
Yeah, this is kind of unfortunate. You have to say nil at the end of a statically allocated array in this fashion. So yes, it is necessary. And so just to familiarize again with some documentation, in Xcode, you can typically go to Window, Organizer, And then there's a whole bunch of stuff here, among which is documentation. All Apple did, they're kind of cutting corners now. This just links to a web page. Frankly, it's a little easier sometimes. If I just pull up a browser, search for NSArray, you'll almost always get it as the top hit or so. This will dive you in deep to the documentation. And now let's just expose a few things. So on the left-hand side, there's a little table of contents. Class methods, instant methods, constants, tasks. These all relate to functionality we've been talking about thus far. Notice on the right-hand side, it tells us the hierarchy. So NSArray descends from NSObject. So that's good. It's consistent with our story thus far. Conforms to, what feature of Objective-C is this list apparently referring to? Protocols. So NS copying is one. Turns out there's a whole bunch of others. NS fast enumeration. The fact that I could do that clever little one-line for loop is because it adheres to that protocol there. So again, this is a way of, you don't want to have a whole hierarchy of things just so that they share functionality. This is sort of like laterally, horizontally sharing functionality. So protocols let us do that. But now let me just go and say, what do we want here? So recall that the method a moment ago was array with objects. So let me search for that. And indeed, under the creating an array subsection here, which is just categorizing things, I can call array with objects. And now, okay, I get some sample usage, and I can now read the docs here and use this particular method. If I go back, though, notice there was one other mention here. If I search for this again, array with objects count, I could actually hard code the length so that I can avoid passing in what? Nil. So there's a way around that. And you'll find that much like PHP, Objective-C or iOS has sort of the kitchen sink of functionality where you might have dozens, maybe even 100 methods associated with a function, with an object. These are the sorts of things that you should never try memorizing or absorbing all of this. It's more of a Control F when you want to find something, or Google to see what a class exposes. Yeah, Aaron.
Is there multiple inheritance?
Is there multiple inheritance? That's a good question. I don't think so. That's my secret glance at Tommy. I don't think so. No. That tends to create some issues, and so usually mix-ins or the equivalent or protocols help address that. All right. So let's add one or two other things, and then we'll break and look at GUI stuff after. All right. So here we introduce one other little thing, which is, let's see. So here's my own convenience method. So this is my student.h. This is now version 9, only one to go. In version 9, in my header file, student.h, notice that I've not only declared init with name, but I've also declared student with name. So student with name is again named in a manner consistent with the idea of convenience methods. The convention is almost always, if the purpose of this class is to return a student or an array, call the convenience method student or array with something so that it sort of does what it says. Notice the plus is important, the ID is important so that it returns a pointer of some sort. And in the M file, here's what I actually do. I take care of the alloc by calling student alloc, then calling my own method init with name and age, which we had before. So otherwise, example 9 is quite like 8, but I've added or stolen this idea of a convenience method from the array class. And lastly, in version 10, we now have this capability. In version 10, I finally realized, you know what, this is stupid. I have declared this prototype atop my file for greet in like 9 previous examples, just so that I could pass in a student and then have that function greet say hello Bob or hello Alice. This is a perfect opportunity to just put this functionality inside the class itself so that I can literally send a message to the object and say, tell me your name. And then the object will say Alice or Bob. So this is a perfect example of a good opportunity for encapsulation. What I really want to do is this: Alice greet, Bob greet, and that message that I send should trigger the printing, the saying of Alice's or Bob's name. So how to implement this? Well, in student.h, I simply have to promise to implement an instance method that returns void. It's just going to use nslog, which is not useful in the real world, but for today it's useful. Greet doesn't take any arguments. And then what am I going to do? Well, the only trickery is in accessing the object's name, but this too is relatively straightforward. In my .m file, I copy the method's signature. I call nslog, hello, I am such and such, I am d years old, and then over here, I simply pass in the name of the instance variable and for age and for name. Alternatively, I could have written this in slightly different form. How else could I have expressed give me your name, give me your age in this comma-separated list of placeholders? Could say self.name, self.age. Which is better? Kind of depends. So on the one hand, it would be, it's better to do it this way with the instance variables. Why, do you think? What's that? You avoid a method call, right? I don't know how expensive a method call is, but it's got to be more expensive than just going directly to the memory location and getting the address. So that might be a plus, especially if we're calling greet in a tight loop all day long. A downside, though, of this approach is what? In other words, why might we instead want to go with self.name or self.age or even self-space age and self-space name as in this syntax here? Yeah, Zach. Exactly. Maybe there's some error checking code in there that's super important to make sure it gets called so that I don't accidentally say, hi, I'm quote unquote. I at least wanted to say, hi, I'm John or something silly like that. So if you want to leverage your own built-in protection mechanisms that are more than just getting a value, you might want to invoke the property or the getter explicitly itself. So which is best? It really depends. Just make sure this is a conscious decision that you've made. And I will say throughout Apple's code, even though there's a bit of a overhead in calling the method, Apple is increasingly just call the property, like just avoid making potential mistakes. So that would not be bad form to just say self.name, self.age. Certainly as the, frankly, phones get faster and faster, quibbling over how you access a property is really not all that interesting an argument anymore. Questions? Yeah?
So now that you're encapsulating the method of greet,
Okay. You can. So what about fast enumeration and greet? You can. So because students is already an array, fast enumeration, it refers to the process of iteratively grabbing the next student in the object. It's kind of independent of the idea of greet. So you could still use fast enumeration, and then inside the loop, just say open bracket, close bracket, s space greet. So you would use this syntax inside of the tight loop.
And the s would be changing as you go.
Exactly. So fast enumeration only refers to, in this context, the updating of that pointer has nothing to do with what's inside the curly braces of the for loop. So where we're going, not to, well, this will get you excited. After break, we will make our own ATM that looks a little something like this, that allows you to deposit money and see your balance and do arithmetic. And it will allow us to have a conversation about how to actually wire up applications slightly slowly, that it will look like this, your very first actual iPhone app. So let's take our 5-minute break here. All right, so now we actually start to dive into the IDE of Xcode and actually making some applications using UIKit and the various user interface widgets that come with it. There's going to be a little bit more new jargon. So again, as before, just honestly, interject if you have any questions, confusions, if I go too fast or too slow. And what I'll do is try to give you a bit of a tour of one or more of the templates, which are interesting in that they are most likely going to be your own starting point, but useful to tease apart verbally so that you understand exactly what has been wired up for you so that you know how all the magic is working. So with that said, and then we'll conclude with the ATM example by doing that a little more manually. So if I load up Xcode and create a new project, recall that you get this interface here. Just be careful not to accidentally start with a Mac OS application because it will look very different. You want something from under iOS. Almost always it will be application category. Here are the various templates of rapid verbal tour. Master detail application typically has some kind of hierarchy, like a list of options. You click on it, slides to the left or so forth. In the iPad might look like the mail application if you've used an iPad. OpenGL game is a very sexy graphical game, assuming you write it to be sexy. A page-based application is sort of like iBooks, where you can side scroll and it kind of peels over to reveal the next page. Single view application is pretty boring. It's just a single rectangle and it's up to you to populate it. That's what we'll use, for instance, for the ATM. And it's also a very useful starting point because it's a clean slate, very little magic pre-wired for you. Tabbed application has the tabs at the bottom of the screen that change what the UI is. Utility application is one of these things where you push a button and the UI flips around and shows some settings, usually on the background, and then flips back around. If you have an iPhone, it's like the weather app or the stock application. And then empty application really does nothing for you, almost to a fault now. So typically you'll want to start with at least single view application or similar. Yeah?
Can you combine features with multiple templates in one application?
Oh, absolutely. You can combine all of these features. These are not mutually exclusive. They are just boilerplate code that you can then add to, subtract from. It's just meant to get you started a little more easily. And these two are a moving target. They've changed significantly since the last version of Xcode. So again, buyer beware with older textbooks or online resources. So let me choose single view application. Click Next. I'm going to give it a name of Demo. Recall that company identifier can be anything. Just choose something unique. It can be edu.harvard or whatnot. Class prefix we'll leave alone. Device family. I'll generally just talk about iPhones because frankly it just fits a little more nicely on the screen. But everything we talk about can equally apply to iPads. And as I said, you can make multiple views so that your device is universal and that it works on both. Storyboards we'll come back to, but they refer to this idea of dragging and dropping and drawing a picture and then adding code to dictate how X transitions to Y. Use ARC, automatic reference counting. Do this. This will automatically do memory management for you now. Again, in a couple weeks, we'll tease apart what this really means and why it's now a good thing for in general. And unit tests will also come back to this idea of being able to test your code in small bites. So the only one for now that you should really check is ARC. All right, so I'm going to click Next. Again, I can check Git repository if you want to do version control, so I'll go ahead and do that. For now, I'm just going to go ahead and save this demo folder on my desktop. So I'm going to click Create, and voila, now I have the template. So as you begin, I would encourage you initially at least hide as much stuff as you can. So at the top right, there's all these icons that let you hide things. Just minimize distractions, because frankly, even this is still a little overwhelming at first glance. But let me go ahead and zoom in at top left. And here are the files and groups that we have by default. So let's pluck off the easy ones first that we can ignore. Toward the bottom is products, which is a group. It's a folder that contains nothing at the moment. It's red because my app doesn't exist. I haven't compiled it, but it's going to end up there. Doesn't matter that it's there. It's going to be automatically transferred to the iPhone. You don't have to double click it or the like. Frameworks. This means this is similar. This is like the linker flag in GCC -L, so that you can link against these various frameworks. You still have to do import at the top of the file, but that just includes the header file. This allows you to link against those files. So if you get adventurous, especially for Project 3, and want to use maps or video or other fundamental libraries, frameworks in the iOS SDK, you might have to right-click on frameworks and add other frameworks there. Otherwise, you'll get compilation errors if it just doesn't know what you mean by UI map kit to do some Google Map type thing. All right, supporting files. Let's also nix some of these as uninteresting. A plist is a property list. This is a whole collection of key value pairs. Underneath the hood, it's an XML file. But this is like settings for your application. For now, the defaults are fine. But among the things you can change here are like, what do you want? Do you want the clock to show or not? Do you want what orientations do you want to support sometimes, so you can do that in code and elsewhere. So those kinds of lower level details. .strings. We won't use this just for now, but this allows you to have translations of your program. So that if you want to have Spanish support, French support, Chinese support, and the like, it allows you, and a lot of languages support this, it allows you to write a string like quote unquote hello in your code, but before that string is displayed on the screen, a lookup happens in this file, and if the user setting is for Chinese or for Spanish or the like, rather than quote unquote hello being returned, the value of hello for that particular language is returned. So localization is relatively easy, and frankly, for those of you interested in startups and the like, and you want to commercialize your application, this is the sort of thing, do it now. Write your code in a way that you've localized your strings. It's super simple. You call a single method that calls a macro really that has a comma separated list of a name and a comment, and it allows you to have this layer of indirection. Slight inefficiency arguably, but worth it rather than having to change hundreds of lines of code or thousands in 6 months.
In the previous file you showed,
Mm-hmm.
can you add settings to that?
Yes, you can, simply by right-clicking and choosing Add Row. Yes.
That would be like if you want like a universal kind of setting for your application.
Correct. Although if you want some universal settings for your app, you would probably not use the default one, which is really SDK specific, and just create your own preferences.plist file and then isolate it to your own application. Demo prefix.pch, this is a precompiled header. This is, again, a file that pretty much gets automatically appended to the top of all of your files just to make sure you have access to certain things. Rarely, if ever, will you have to touch that file. Don't delete it, but it's there. So I mention all of these really so that you can cross off your mental list things that you need to care about just now. Lastly, main.m. Surprisingly, this too, you don't really need to care about. It exists. It imports UIKit because we're making a GUI app now. App delegate, we'll see what that means in a moment. Here's the main method. And it apparently returns UI application main ... That's it. Rarely, if ever, should you have to touch the main method. It exists to bootstrap the whole process because Objective-C is built on C, so you need a main function. But all of the magic is going to happen in other files. So generally, never touch this file, but know that it exists. All right, any questions on all the stuff you can ignore for now? All right, good. So let's hide this, hide this, hide this. Look how simple iPhone programming is getting. All right, so what actually now is happening? So when you click Run, let's see what this thing does. I'm going to go ahead and hit Command R. And the progress bar is going to compile. It's going to launch the simulator. Depending on the speed of your computer, this might happen slower or faster. That's a single view application. Out of the box, no code changes, nothing. That's what you get. Now, I can click all day long. It's not going to do anything. But there's the rectangle that I promised, a generic gray box filling the whole UI window. So we can start populating this with some stuff. But let's just do a simple demo. So here's my view controller.nib. Even though it's XIB, people say nib. I don't know what a view controller is yet. We'll tease that apart. I'm ignoring app delegate for the moment. But let's just actually add something to our palette here. So it's hard to see on the projector, but this background here is like graph paper. So it helps you size things and lay things out. If I want to add some widgets to this thing, let me expose the right-hand view. And as I mentioned a week or so ago, this is where Apple hid all of the otherwise complex stuff. At the bottom here, notice that we have a whole list of objects. And there's some fun stuff here, right? There's a label, there's a button, there's one of these toggles, text fields, sliders, switches, progress views, page control, all of the little fancy widgets you have seen on iPhones or equivalently Android and the like. You can drag and drop them. From here, realize that there's menus here for objects and other different things. So if you get confused, just kind of click around until you see what you're looking for. For instance, this is just a list of classes. If you want to instantiate one of these classes in a certain way, this is frankly, this is useless. This is like if you forget the syntax of the language, you can drag and drop this and remind yourself. This is where you can play movies, or drag and drop movies at least. So I'm going to click on the little one that looks like a generic object, this cube, and let me go to the label. And I'm just going to drag and drop the label. Now, this is not iPhone programming per se, but it's one way of just expediting the process. All of this could be done in code, and that's what we'll do eventually anyway. So here's this label. I'm just going to say hello. If I want to change the aesthetics, I can click it. Then up here, there's all these things called inspectors. I always forget what the icons means, but if you hover over it, this is the file inspector at left. This is the quick help inspector, identity inspector, attributes, size, and connections. This one's actually super useful, this quick help. When you're in code mode, if you click on almost any variable or function these days, you'll see a little cheat sheet on the right-hand side that reminds you what it is, what its usage is, what its parameters are. So there actually is some really compelling features of the IDE. I'm going to care about the attributes for now. And notice this is like Microsoft Word style tweaks that you can make to the aesthetics. I'm going to go ahead and increase the font size by clicking that a little bit here. I'll go ahead and let me click on the background, change the background to, let's say, other. Let's go ahead and choose, let's say, some crayon colors. We'll do lavender. And OK. So now proof that I'm actually making an iPhone app. So let me save it. Command R to recompile it. And with it, this nib file. As an aside, a nib file is just, all right, I didn't make the box big enough. A nib file is just an XML file. Oh, it's all right, dot. Next time we'll see what the rest of the sentence says. So what is a nib file? So if you open it with a text editor, the XIB file, it's just an XML file. It is not an XML file you should ever touch manually or edit because there's crazy constants in there and arbitrary values. It's just a way of representing this drag and drop GUI interface. And the idea is that it can just expedite creating an interface so that you don't have to do everything in code. Frankly, it's very tedious in code to have to say, I want this text area to be 17 pixels by 34 pixels and positioned up. It's just very tedious. You can do it, and sometimes it's better because it just gives you more control and you don't have to hide details with this drag and drop interface. But initially, this is a useful way to get started, certainly for the simplest of applications. So let's now close the demo application and go into the code and what was happening here. So the first file to talk about, and almost all of the templates have a file called this, appdelegate.h and .m. This is really the guy that's in charge of the program. When main is called, and it calls that UI application main function, that effectively hands control of the entire device off to this class, an object of this class that's created for you. So in the header file here, notice a couple of things. In appdelegate, the guy in charge imports the UIKit header, so you can do stuff with GUIs. It imports, actually doesn't import, there's this keyword, class view controller. So this is just one, I think this is the last real new piece of syntax today. At class is kind of like a function prototype in that it's a hint to the compiler. This class exists. You might not have imported it yet. You'll eventually see it. But just so you don't freak out, here's the name of it, so I can mention it later as I do down here. All right, so next up is @interface appdelegate. So UI responder is an Apple-made class whose purpose in life is to respond to things. And for now, let's oversimplify this by saying the appdelegate, because it's in charge of the whole program, surely it's got to be able to respond to things like touches and presses and drags and swipes and the like. So appdelegate descends from that class. And what does it mean in angled brackets here, UI application delegate? That means that appdelegate does what? Uses that protocol, or more properly, implements that protocol, which means this class implements the methods that are declared in that protocol. This is similar in spirit to the copying protocol that we saw before. For now, I don't really know or care what it does, but just know that it's standardizing what an appdelegate actually is. Now, we have two properties here. We haven't used the word strong before. We'll come back to that. It has to do with memory management. But for now, we'll almost always use the keyword strong instead of assign when it comes to pointers. So for now, that's a reasonable rule of thumb. But we'll tease that apart eventually. So here's this pointer. Apparently, out of the box, an application has a pointer to something called a UI window. What's that? It's just the rectangle of the screen. So that's good. Just intuitively, if this is the thing that's in charge of the application, he's got to have some way of communicating with the piece of glass, and so that you can actually draw things on the screen, listen to key presses and the like. So this pointer is that way of conversing back and forth with the physical device in code. The second thing here, view controller. Well, view controller is just a controller. So really, the appdelegate is going to hand control off eventually to a proper controller that who wrote? Us, for the most part. So you'll sometimes add functionality to the appdelegate, but generally your code will be in controller classes. And maybe not just one. Recall from CodeIgniter, you can have multiple controllers. So even though the appdelegate is ultimately the thing in charge, he can hand control off to this view controller, this view controller, this view controller. And for now, you can think of a view controller as just a different screen of options. Each screen might need to scroll independently of others, so it's got to control the user's experience. So thankfully, we have a view controller file here, so there's already someone to whom we can further hand off control. End means we're at the end of this file. So now just remember that, again, an appdelegate has a pointer to a UI window and to something called a view controller. So now let's look in the view controller.h class. Phew, doesn't do anything. All right, so out of the box, this view controller doesn't do anything, and that's pretty consistent with the demo we saw, right? Before I dragged and dropped anything, it didn't do anything. It's because there's no code here, or nothing interesting, at least in the .h file. But what is interesting is that view controller descends from a standard class, UI view controller. So Apple could have called view controller foo, or just controller, but it's just their habit of calling it a view controller. So let's look at the M file for the view controller class. So again, this is like your index.php in CodeIgniter, or rather the controllers you yourself wrote in your controllers folder. So here now, is viewController.m. And out of the box, there's a little bit of code here. So let's see what's going on. So first, it imports its header file. This is not all that interesting. There's this, which frankly is a little annoying of Apple. You can, with that feature called, what do the parentheses imply? Categories. You can actually have additional private methods and private properties, and they can go inside of the lines I've highlighted. So when you declare a category with no name, the jargon here is that you're making a class extension by not so much adding new functionality to the class, but hiding functionality. Because notice, where are we? We're in the .m file. That means if other people include my code, they won't see anything I write in the highlighted lines here. So for now, I'm actually going to hit delete in a moment, and we're just going to ignore this detail for now. But just realize this is a new convention in iOS of creating effectively private methods and or private properties without using the @private keyword. But without, let's not overwhelm just yet. Let me just delete that, and we'll come back to it eventually. So here now is the implementation of the class called viewController. Now, none of these three methods, and I see there are three because there's three hyphens, none of these were declared in the H file. Recall the H file had nothing in it. So where did the declarations of these three methods come from? The parent class, right? So we've seen this before. Just as we didn't declare the init method explicitly because NSObject took care of that for us, same deal here. UI viewController is my parent. He's probably declared these various methods. And I could confirm as much. If I Google UI viewController, I'll see a huge list of all of his methods. And I'm simply overriding three of them here. So view did load. What's nice here is that these methods pretty much do what they say. View did load means that you're at the point in your program where whatever you've drawn, say in the nib file, the little stupid hello text and the purple background, that has loaded and is visible now. So this method is called as soon as that happens. And that's useful because you might want to tweak the user interface. I might want to change hi to bye or something like that. This is your opportunity once your nib file has been loaded to do some stuff. View did unload is the opposite. Maybe when the view disappears, you want to free some memory, although that's not something you need to do so manually anymore. Maybe you want to close a database connection or log something. Whenever that screen disappears, you can do something. So this is essentially like an event that gets triggered, much like in JavaScript, if familiar. And now this is a crazy named one. Should auto rotate to interface orientation? Remarkably, this does what it says. This is a method that's supposed to return yes or no, true or false, if the device should be allowed to rotate to the specified argument. The argument is actually a constant. So UI interface orientation is an enum, I believe. And an enum, recall, is just a comma-separated list of constants. So what this default return value is saying is return interface orientation, which is the argument. It's a big font, so it's wrapping onto two lines, but it belongs over there. So if it's not equal to UI interface orientation portrait upside down, return true. So logically, return yes. So this one-liner is saying, let the app work like this, like this, like this, but not like this. So in other words, return no if the user has the thing freaking upside down completely. But it's OK if they have it in any of the three other orientations. This is just a common Apple thing. Like they just want the button at the bottom or the sides. They don't want it completely upside down. But we can override that convention by just returning always yes, literally. So this is just a method that essentially what's going to happen is when the user has the device in his or her hand and rotates it, this method's going to get called, going to get called, going to get called. And anytime it returns true, the UI will actually rotate. Anytime it returns false, it's going to stay where it is. So this is why if you have some games or other applications, sometimes it'll rotate. But if you go too far, it just won't until you go another 46 or so degrees. Then it'll flip around further. So this is just an example of what you get by having your controller class descend from some fancier thing that Apple wrote that has some built-in functionality. Frankly, it would be annoying if you and I had to figure out the geometry and mathematics of rotating the screen. So these are the kinds of shoulders that we can stand on. Now, as for these two methods, notice that the only thing viewDidLoad and viewDidUnload are doing are calling the superclasses equivalently named method. That means, for those less familiar with OOP, object-oriented programming, I can actually get rid of that. Because if I don't override the parent class's methods, they will just get called automatically. The reason that I have to call super is because if I do want to override them, the convention is I better at least commit to the parent still doing whatever it wants to do, then do my stuff. But if I don't have any actual work to do, which I don't in my silly purple application, then I can just delete these altogether. There's no value of overriding those methods. All right, so I'm just going to delete that just to simplify the template for now, even though there's no functional change. Well, the last file to look at is appdelegate.m. So let me go into the M file here, and let's see what's in here. Unfortunately, this one's a little more overwhelming, but thankfully it's all comments, so we're about to hit delete again. So here we go. In appdelegate.m is the implementation of my application delegate, the thing that's in charge of my application, the thing to whom what function hands off control. Quick sanity check. Main. Main effectively hands off control to an object of this class. All right, so this class is doing what? Well, it's importing its header file. That's normal. It's importing the view controller. That's normal if it's going to mention it down below. Here comes the implementation of this class. Notice you don't mention the parent class in the M file. You only mention it in the header file with the colon. Now, synthesize, this is like pre-break stuff, right? I'm just synthesizing the window and the view controller properties. And now we have a method called application did finish launching with options. OK, takes two arguments, application and launch. And this, remarkably, this is really the method that kicks off things. When the app delegate is handed control, once everything's loaded from the flash memory in the iOS device, this is the method that's called so you can start doing your thing. You can start creating your user interface either via a nib or manually via a whole bunch of method calls. This is where you can load a database. This is where you can draw a picture on the screen that says like loading ... This is where you have an opportunity to get your application started with any startup tasks that you might have. So this template is doing a whole bunch of stuff for us. That's why I was able to run it out of the box. So what's it doing? Well, first, it's assigning to itself its window property, which recall is just a pointer initially, a nil pointer. It's allocating a UI window, whatever that is. For now, it's a big rectangle that fills the screen. It's a special view. I'm allocating it. I'm initializing it with a frame. What do I mean by frame? Well, I keep saying it's a rectangle, but iOS devices have different dimensions. So I better dynamically figure out what those dimensions are. I can do that. I can ask the UI screen, which is a special class that refers to the glass, really. Give me your main screen. This refers to the actual glass. You might know that you can mirror screens now with like a VGA cable or with an Apple TV. So there might be a second screen elsewhere. So main screen just refers to the glass. And then give me your bounds. Give me your X, Y, top, bottom, that kind of bounds, so that I can say, have the UI window fill the frame, the entire rectangle of the screen, however many pixels or points that is. All right, so that's all it does. The next line is just a comment. This is Apple saying, OK, put your code here. But we're going to ignore that, and let's move on to the next line here. What am I doing next? Well, as the app delegate, I want to adhere to, really by convention, the whole MVC architecture. So to do that, I need a controller. And I maybe need a model, and I probably need a view, but I at least need a controller. App delegate is not a controller. This is sort of the app delegate exists independent of the whole concept of MVC. But it's up to him to create a situation in which we have an MVC architecture. So he's going to create a view controller object with alloc. He's going to initialize it with the nib whose name is viewcontroller.xib. By default, it's implied. So what does this mean? This means that it's going to create this object of type view controller, and it's going to tell him what file to use to pre-populate its default view. So there's a little commingling of of C and V here, but ultimately the thing in charge of the view is the controller. So this is creating a controller, and it's handing him a default view that's ultimately going to fill the screen. All right, and it's storing it in my view controller property. And the bundle, this just refers to where on disk I can store stuff related to this. A little more than that, but for now, nil is fine. All right, any questions conceptually on these two lines of code? Don't get lost yet. Yeah?
The UI in it with frame, can you have it like change the bounds so that you only have like a half screen on your app?
Good question. Can you change the bounds of the UI window so it only takes up half the app? You could, but you wouldn't for the UI window. The UI window is really meant to fill the window. Instead, after creating the window, you would create two children of the window. One is a UI view that's half of it, and the other might be the second half. But those are going to be attached to the bigger UI window, just so you have access to everything.
I would say more like if you only take up
Oh, good question. No. So if the UI window only takes up the top half of the screen, could you secretly see your Springboard and all of your applications and your email count? No. I think you would just see gray or white. Good question. Or black even. Good question. I'm sure we could answer that. Yeah. Easy test, though. Yeah.
Could you technically say UI screen dot main screen dot bounds if those were properties?
If they were properties, and I don't believe they are, simply because Apple decided that they are not. Could be wrong, and we could quickly check the documentation for the UI screen class. But yes, if they were properties, you could do that. Other questions? All right, so what's next? Self.window.rootViewController. All right, so this is another convention here. So recall that I am inheriting from the UI view controller class. That's, again, a special class that Apple wrote that gives me a bunch of stuff for free, screen rotations and other functionality. Now, if I'm going to use that, the documentation says that I have to inform this UI view controller of its default root view controller. So in other words, I need to tell the window, let me back up. The window object is who needs to know who the default controller is. So just as main passes off control to the app delegate is going to pass off control to a controller. Who is the default controller? The first one you see that gets control? Well, it's whoever is the value of root view controller. So the window has a special property, which is a pointer to a view controller, and that's just the default one. In my purple application, there's only one, so there's no complexity here, but surely with more interesting applications like the Mail app, you might have multiple controllers, each do different things. You at least need a default. It's probably the inbox. In that case, is the default view controller, so the root view controller. So self.window.rootViewController gets self.viewController. Now notice you can nest properties in this way. If you call something.something.something, totally legitimate, but just realize you're invoking most likely synthesized getters or setters in this case. All right, lastly, this line tells the window, make yourself the key window and visible. Key window essentially means you're the one that responds to finger touches, and visible means show yourself. And then we return yes, signifying the application did finish loading with options. Launching with options. Yeah?
If you didn't do that, your application would show, but it wouldn't respond to anything.
Well, let's see. So which, if you didn't do that, define that.
You didn't do the self window and make key and visible.
So this one here?
Not those two, just the bottom one.
Oh, just this one.
Yeah. Our application doesn't do anything, so.
Indeed, now it does even less, right? So that's what it does. So, and admittedly, for time's sake, I'm not testing all of our questions sometimes, but this is absolutely good practice. Like when in doubt, just try it. Save your work, but certainly try it. Good question. All right, so what else is in this file? Well, thankfully, a whole bunch of stuff we're going to delete in a second, but just so you know where some of the magical behavior is coming from, notice that the UI app delegate class that we're descending from also has some other methods. Application will resign active. And the comments essentially define this. But now there's backgrounding apps in iOS whereby you hit the home button and then the thing disappears. You have the ability to respond to those events. So just as JavaScript is very much an event-oriented language, so is Objective-C in this case. So you can do something there. Did enter background after that has actually happened. Application will enter foreground right before it comes back up. So there might be things you want to do. Like the Mail app, you don't want it checking your mail in the background necessarily, but the moment I re-click the icon and bring it back, maybe Apple wants it, just then recheck the mail server for efficiency. So you have this ability to respond to these events. Application will terminate here too. If the user is trying to force quit your application, you have the ability, or rather, if you're trying to quit the application, you have the ability to intervene at the last second. But there are constraints. If you kind of try biding your time and spend 30 seconds doing something, cleaning something up, you're going to get killed by the OS. You have, I think, 5 seconds maximally, and that's actually a little high. So this is not meant for long-winded operations. This is for super simple cleanup, like quickly save the high scores or quickly update the settings or something simple like that. But for now, I can delete all of that so that now my application is whittled down to relatively few lines of code. So what you'll see in the printout here today and on the website, the application I called single view is literally the result of my creating this template, then ripping out everything that you don't need to care about initially. So if you want, you can reread through that code just to focus on the germane things. But if you start with the fresh template, you'll get a lot more detail. Any questions? Yeah, Zach.
So what's the relationship between the nib file and the .m file? Because I think sometimes in like IDEs they'll like create the code for like the things you put in the nib or like in the view in the code.
Good question.
Does that all live in the nib file?
Good question. What's the relationship between the nib file and the .m file? Short answer is it depends on the template and on your own design decisions. Generally, the nib contains your user interface or a subset thereof. And by user interface, I mean where are the buttons, where are the text fields, where are the scroll bars and the like. All of that, though, can be implemented in code, and you can delete the nib file and do all of that in code. Some of the templates, even that Apple provides, do all nib-based UI, or they do all code-based UI, or an amalgam of the two. It really depends. And this is slightly one of these religious things where some people just hate using interface builder. Interface builder is just the jargon that refers to the drag and drop interface inside of Xcode. It used to be a separate program years ago. Some people prefer all code. I think, frankly, sometimes it's just easier to start doing it with interface builder and then do a few tweaks in code, but it's a design decision.
But you can go into the .m file and like change variable, like change the label.
Yes. Oh, absolutely. If you drag and drop things into the nib file, you can then programmatically change what you did in code. They're not mutually exclusive, but the nib is typically loaded first. Good question. You can think of it, the nib is technically supposed to be a serialized object. So if you think of your user interface as an object in memory, the nib file, even though it's XML, is like the result of converting it to a crazy long cryptic string so that you can unserialize it later and reconstruct that same user interface. All right, so let's make this ATM, and we get to introduce the event handling model of iOS and something called actions and outlets. All right, so here we go. I'm going to go to, oh, and do be careful, like I just screwed up. If you hit Command N for new, it asks you to choose a template for a file. That's not what I want. Command Shift new gives me a new project. Or if that's confusing, just go to the File menu and make sure you explicitly choose New Project, not New File. And then you'll get the right templates. All right, I'm going to go ahead and start with a single view application because it'll give me a little functionality like rotation and whatnot. I'm going to call this ATM. I'm going to leave all of that checked as before. Click OK, or rather Next. Put it on my desktop for now. And here we go. Back to the same starting point that we had before. So I want to implement an ATM, and you saw a glimpse at the interface earlier. So let's dive right into the interface and then worry about how to implement the model and the controller itself after that. So I'm going to go into my nib file. So on the left-hand side here, I have viewcontroller.nib. I just have one nib. That's fine, because I'm going to have one interface. So let's do some fluffy stuff first. Let me click on the background here. Let me change the background from being gray to white. All right, so now it looks a little less boring, or maybe more boring, depending on your perspective. Now let me start laying some things out, and I'll try to zoom in and out as needed to make this clear as to what I'm doing. So I first want a label. I kind of modeled this in my head after like an old school calculator with the little readout on the top. So I'm going to go ahead and drag and drop a label at the top of the file there. And I'm going to say this is where the amount is going to go. That's just a placeholder. It's going to become numeric, but just to keep myself sane, I'll do that for now. Let me increase the font size to, let's say, 24 there. And let me just drag here. So kind of like Photoshop and InDesign, if familiar with those products, you can drag, and then it kind of has guidelines to just propose. Why don't you let go there so it's not too close to the edge of the glass so a human finger can still interact with it okay. I'm going to go ahead then and center it here. Rather, right align it like a calculator would be, or an ATM in this case. So now I have my text field. Now we're going to see in a moment how I can programmatically edit the contents of that string from being amount to being like $0 or something like that. But now let's do some buttons for the mechanics of the thing. So I'm going to drag and drop this button here. It's suggesting where I put it, but I can override this if I want. And I can absolutely make these things prettier. You can add skins these days and gradients and even graphics and the like, but we'll just keep it more focused on code for now. This is going to be the number 9 over there. I'm going to just copy and paste this and drag it onto the other side. This will be 7 over there. Copy and paste this. Notice it's figuring out the centering for me, so that's nice. This is the kind of stuff that UI Builder, Interface Builder just makes easier. But you could do this all in code. But now I want to do something else. This is slightly This is some forethought here. So I'm scrolling, because I never remember where it is, and there it is. So it turns out that the thing I just dragged here, the number 7, let me go up to the identity. This is the identity inspector up here. Notice that because I've clicked on the button and I've chosen that inspector, it's telling me what class this little widget is. So I dragged and dropped this button. That's a specific type. It's a UI button. That happens to descend, I know from the documentation, from UI view. And this is only to say that because it's a UI view, it's got some standard information inside of it, besides font size and all this fluffy stuff. One of those details is something called a tag. So I'm actually going to specify I want this button to be tagged with an integer, the number 7. So I can uniquely identify it later when the user touches this button, independent of the aesthetics. So notice, this is fundamentally different. This is the difference between view and really the model here, where the UI button is a model class. I want there to be a numeric piece of data associated with this button in addition to the aesthetic string that coincidentally is on top. And I can make this distinction even more explicitly. Suppose this were a really annoying ATM, I could say 7 there, just to make more clear the duality of a machine-readable number and a human-readable string. So that's what's called a tag, and it's just a property of the UI view class. So I'm going to quickly do that for 8. Let me change its tag here to be 8. And let me change its tag here to be 9. This is not something you always have to do. This is just because I thought this through and I realized I want to touch any of 9 or so buttons. I need to be able to determine with the same method which button the user touched. Yeah?
So is the tag just an ID that you're interpreting as an int? Or is
It is an int called tag, and I can use it however I want.
Okay.
It's typically used with enum constants if I were doing it in code.
So it's not like an ID in an HTML tag?
It's not a unique ID. There can be duplicates. Hence the name tag. So let me do this quickly now. I'm going to copy and paste these 3 buttons here. Let me quickly change this to 4, to 5, to 6. Let me quickly change their tags by scrolling down here. Tag, this is going to be 6. This tag is going to be 5. This tag is going to be 4. All right, and now let me, one more time, copy, paste. All right, this is going to be 1. This is going to be 2. This is going to be 3. Now I just quickly have to change this. 3. This is why, at this point, code with a loop would actually be kind of compelling. But this is just one-time configuration. All right, and then I need one more row of buttons, let's say. And this is going to be 0 in the middle. And let me give it a tag of 0. And then this guy here, let's call this clear. Let's call this deposit. And just to be fancy, let me change my text color to be, let's say, fern. OK. We've got a 99-cent app coming here. All right. And all right. Turns out these tags won't matter, so I'm just going to leave them as 0. But as we'll see in a moment, it's actually immaterial. So I've got that. Now let me do one more thing. I want to know my total account balance always. So let me go ahead and put a label down here. Call this balance. Let me go ahead and stretch it out to be the whole width. Let me go and change the font size to be as big as the other one, 24 point. Stretch this out further over here. Center this. And actually, we'll just say 0 initially. Make it a little taller. And then just so I have a little label to remind me of what that is, I'm just going to say balance in small text there. OK, so that's it. This is the value of something like Interface Builder. Ugly though this is, I mean, that was much quicker than I could have done it in code, figuring out the various layouts and the like. Know that there exist built-in features in Xcode whereby if I want to support a left-right rotation, I could actually tweak the definition of these things, locations, to say, that's OK. If it rotates, just grow to expand the screen or the like. So it doesn't have to all get oriented in like the top left corner, quite ugly fashion. So realize there are those features as well. But the more interesting part now is how do I actually implement the rest of this program? Well, let me go ahead and do this. I need some way of maintaining someone's account balance. So I'm going to go ahead and do this. I'm going to go up to New. Let's right click on here. Let's go to New File. I want to create a model class. Now, what's a model class? It really depends. Just like in CodeIgniter, you can create a model to represent a student or a course or a professor or whatever you want. I want to represent something like an account balance. So I'm going to choose under iOS an Objective-C class. I'm going to click Next. I'm going to call this account. I'm going to tell it to be a subclass of NSObject. I'm going to click Next. It's going to ask me where to save it. That's fine. I want to save it inside the ATM project. And voila, what I now get over here, and I'll put it alphabetically at the top, is a generic class called account. Now, what do we need to associate with a user's bank account? Keep it simple. The balance, like how much money do they actually have. So what I'm actually going to do then is inside of the interface here in the .h file, I'm going to go ahead and say, all right, well, a account is going to have a property. I don't know what attributes it's going to have yet. It's going to be an unsigned long value called balance. Now, because this is a long, should it be copy or assign based on last week's conversation? What do you do with primitives usually? So, okay, the opposite. So it was assign. Copy is used for generally pointers or strings where you want a true copy. With assign, it suffices just to copy the raw bits because it's a primitive. And this, again, just pertains to how synthesize is going to behave. Give me a setter that just does a raw copy of bits, nothing fancy. In addition, non-atomic will give me an ever so slight performance benefit so that it doesn't worry about multi-threaded code. And that's it. This gives me a property called balance associated with a class called account. Now let me give myself a little bit of functionality so that I can actually use this account. And to do that, in my M file, I'm going to go ahead and say @synthesize, and the property name is going to be balance, and it knows that, equals underscore balance, and it even knows that, enter, semicolon. And now let me go ahead and create an init method here. So I'm going to do ID init, just like we did earlier, even though I'm writing it on the fly this time. So if self gets super init, and again, this is boilerplate code that you should almost always write when creating an init method. I'm going to go ahead and do self.balance gets 0, and then return self. In other words, when the account itself is constructed, initialize your balance to 0. As per our earlier conversation, I could do underscore balance gets 0, or I could use the property. I'm just going to get into the habit of using the property, the setter in this case. So that's it for an account balance. I just needed a model class to represent an account so that I can actually now do something with regard to the notion of money. So what do I next want to do? Well, I can pretty much leave alone the app delegate because I'm going to relegate almost all of my interesting code to the view controller. So let me go into my view controller and do the interesting part now when it comes to code meeting nib files. So inside of my view controller, and if you want to sort of spoil the results, all of this code is in the ATM example in today's printout, an online code. I'm going to go ahead and import the account class, or the account header file, so I can actually use it. In terms of the view controller, I don't actually want any instance variables per se, at least ones that aren't properties, but I do want a few properties, one of which is going to be an account. So I'm going to give myself a pointer to an account, one of which is going to be a, let's say, unsigned long amount. What am I going to use this int for, do you think? What's this int going to represent in the program? Just literally that dollar amount. I need some variable, some 32 bits or 64 bits to represent the number that the user's typed in before it gets deposited in their account and in turn in the unsigned long called balance. So I'm going to put that into my view controller here who's controlling this interface. So this is my .h. App property, I need a couple other things now, and this is the new feature for now. IB outlet, interface builder outlet of type UI label, and it's going to be called arbitrarily the balance label. And then I want another property that's an IB outlet that's also a UI label that's arbitrarily going to be called deposit label. In other words, I have created an interface builder by dragging and dropping 2 labels, 3 actually, but only 2 of which I care about changing. The amount at top right and the balance at bottom middle. Programmatically, if I'm going to update those things, I need some way of wiring, so to speak, my code to that GUI interface so I can talk. And how do we do this in C? Pointers. Pointers allow you to access something elsewhere. So by saying UI outlet, this is going to allow me to create in the nib file literally a solid line from one thing to another. So we'll see that in just a moment. So as for the properties, I'm going to fly through this a little bit, mostly because we've already talked about these things. They're all going to be non-atomic, but for today, take for granted that you want to say strong almost always when a pointer is involved. Not copy, not assign, you want to say strong. But again, we'll tease that apart when we talk about memory. This case here, it's just a primitive, so I'm going to say non-atomic, assign. And I'm a little anal. I just do these things alphabetically, but you can order them any way you want. Non-atomic for this one, strong, and then non-atomic, strong for this one. So in short, we'll spend more time in memory management on these parentheticals. But for now, all we have is 4 properties. The only new feature in this conversation is IB outlets. And we're about to add one other detail. So in addition to these properties, I'm going to have a couple of methods associated with my controller that I can call. And these return types are going to be called IB actions. And that's the second and last new buzzword now. Clear is going to be one method. And that method, I'll tell you, is meant to clear the interface. When I hit the clear button, I want the numbers to go away. I have another IB action now whose name is going to be deposit. This is going to be the method that's called when I actually deposit a value. I have another one here, another IB action that's going to be digit. This is the method that's going to be called anytime a digit is touched on the interface. And lastly, I have another IB action that, no, I don't. I have another method called void, return type void called show. And this is just going to be a method, as we'll see, that's going to update my user interface. Thank you. Perfect. OK. So in short, I have 4 properties, 2 of which are something called outlets now. I have 4 methods, 3 of which are called actions. Actions refer to methods, outlets refer to properties, and these things, as denoted by the silly looking circles there, are now going to allow me to wire things up in my user interface. So let's see what I mean by that. So I'm going to go back to my nib file. And this time, I'm going to first click this arrow just to give me more room here. Notice to the left of the graph paper, you see a sort of textual representation of all of the widgets that I've dragged and dropped. So notice I've got the big view, and then I dragged on top of that view, the rectangle, all of those buttons. That's why they're appearing there. At the top are 2 special placeholders called files owner and first responder. Let's ignore first responder for today, but files owner is actually relatively straightforward. That is an icon that represents the owner of this nib file. The nib file is called viewcontroller.nib. The owner is then viewcontroller.m in this case. So because I now have a graphical representation of my M file, I'm going to be able to connect dots, so to speak, in this picture. So here's what I want to do. I want to go ahead and hold Control and click on the 7 and drag over to Files Owner. Notice how it's highlighting and literally a blue line is being drawn. And let go. And what I see here is a list of events. What events can I invoke when 7 is pressed? So what method do I want to call when 7 is pressed? Digit. So I'm going to go ahead and select digit. And sure enough, if I now control click or right click on the 7, I see a whole bunch of events that this button could send. Turns out you can do a lot of things with a button here. Touch up inside is literally that, like touch and then upwards inside of the button will induce this event. So that's the idea of touching a button. What that means is, because there's now this connection, when you touch up inside the button, the file's owner's digit method will be called. And you know what's going to be passed to the digit method? Well, what was its parameter called? It was called sender. Remember I did this, and I didn't mention what I was doing at the time, but notice I did this, ID sender. Take a guess. What are you going to be handed a pointer to in your digit method? The button. And because the button has that thing called a tag property, this is how programmatically I'm going to get access to the number of the button and then actually do something mathematically with its value. Now let's do one in the other direction. It'll get tedious if I wire them all up, so I'll sort of pull a pre-baked application out of the oven and show you how this works in a moment. Let me go ahead now and drag holding Control from Files Owner to Amount and let go. Notice now in the opposite direction, because I have outlets in addition to actions, I can now connect my M file programmatically to the labels. And so now this is the deposit label. I can select that. Then let me do it again. Control on file's owner down to this label, not this one, and let go. I can then connect it to balance label. So what does this mean? Even though I've created my GUI using this drag and drop interface, recall that in code, I have these 4 pointers. Well, normally in CS50 and in C and in Objective-C more generally, if you want a pointer to have a value, you better use the assignment operator. You better use the equal sign. Well, what I've just done is I've supplanted the equal sign with this big blue arrow that I drew that is doing the assignment for me. So when I click Command R to run this program, this view controller object is going to have these 4 properties, 3 of which are pointers, and those pointers will automatically point to the address of what objects in memory? The UI labels in memory. So I don't have to instantiate UI labels because they're in the nib. That will happen for me automatically, but now that pointer will be set for me. So now if I open up the prefabbed version of this code, just so I don't have to tediously drag and drop for all of those buttons, you'll see that if I go back to my nib file, I've done the same exact thing here. And if I control-click on file's owner, notice how much work I did here in wiring things up. This is just an exhaustive list of all of the connections in different directions that are now wired up, either the pointer assignment or the event handlers that are configured. So if I now go ahead and hit Command-R and run the entire code and pull up the results here, notice I can type in something like 20 and then click Deposit, and it ends up over there. I can do 11, deposit, 31, goes back to 0. And I can do this now programmatically because I have pointers controlling those labels and the underlying code. And the underlying code, if we look at the M file, is actually relatively straightforward. Let's just look at 1 or 2 in closing here. This is the digit method. I declared it in the H. Here's the .m file. What do? Well, I first cast to a UI button the sender, because it's a generic ID, which is kind of like a void star, but that can also be nil. I just want to treat it as a button, so that's common convention there. Then I want to update the amount in the screen, so self.amount. This is my int property, or unsigned long, equals self.amount times 10 plus b.tag. And this is just a brilliant way of moving the digit that's currently on the screen one place to the left, right, multiply by 10, then add in whatever the numeric value of the tag is. And the reason for the tag to be clear is it would just be hackish to look at quote-unquote 7 or quote-unquote 8, which is a string, then convert it back to an int. The tag is just a better design in that it's defined as an actual int. And then if we look at something like show, notice that showing the interface after I've clicked a button is going to involve updating self.balance label. It has a text property, which is literally an NS string pointer. And I'm going to put in that pointer the result, if you think back to 50, a string that's formatted with LLU, which is unsigned long, self.account.balance. And there's a few details we didn't peel apart there, but the biggest takeaways, hopefully, from today's example there is how you connect GUI to code so that they can then start crosstalking. And that's where we'll pick up after spring break. So we'll see you then.